Hi everyone, my name is Sachin, and as the slide suggests, the title for this talk would be Supercharging Initial Foothold in Red Team Assessments. Before I start, I want to thank organizers and sponsors of Cocoon, and especially people behind Red Team Village for giving me this opportunity to share my knowledge. And these people have been working extremely hard, so I want to give it to them, and I'm really looking forward to the questions which come forward. So a little bit about myself. My name is Sachin, and I lead the offensive security team in Axiata Group, which is based out of Malaysia. I'm a purple teamer. I mostly do red team assessments, but sometimes I go to the other side of the table and do blue team assessments as well. I also enjoy doing a lot of Active Directory exploitation because that's where most of the corporate world is currently residing, and the world of Active Directory truly fascinates me. So I do a lot of research around that, and on top of it, currently I'm doing my research on deception technology, where you would deploy a lot of honey tokens and stuff, and I'll be talking about that a little later. I'm also doing a little bit research on cloud because that's where most of the people tend to be these days. Apart from that, I do a fair bit of gaming, and you can find me on Twitter and GitHub under the handle Ponfu. A quick disclaimer before the talk, right? The opinions and views in this presentation just belongs to me, so it does not tie back to my employer. And this is based on, although the case studies are based on some of the work that I have performed, nothing in this talk actually ties back to my employer. So the talking points of this talk, what we'll be doing is we'll be basically covering the 101s. I'll quickly walk you through the basics, just in case you want to brush up. We'll be talking about the methodology of attacks, or especially using NTLM Endpoints, which has been around for a lot of years. We'll be talking about attacking Windows services, mostly Exchange, and we'll talk about how to pivot from that into the cloud, which is especially Office 365 premises. We'll also discuss some blue team tips because that's required when you do an attack. You need to learn about the defense as well. So we'll be talking about that. And finally, we'll wrap up the session with a quick Q&A. If you have any questions, we'll take that at the end. So first things first, we'll brush up on a few basic topics since it's a mixed audience. So I thought I would just put in the slides real quick. So what I'll be primarily talking about is NTLM endpoints. So basically, these are endpoints which are used by Windows for authentication. Right? So this has been around for many years. This is one of the primary authentication which has been present in Windows, and this was basically there before actually Kerberos was cool, or Kerberos actually became popular. So NTLM authentication was the go-to a lot of years back. So quickly on how this works is basically you have a user request access to the server, and basically like any other authentication, and some of the Exchange authentications, there is a challenge message. The client sends a response message and server responds back with if it's successful or not. But what happens in the backend is that the server actually sends this challenge to the Active Directory, which is basically the heart and soul of a corporate environment which uses Windows. And that authentication goes to the AD, and the AD comes back saying if the authentication has been successful. And that's the basics of how NTLM works. So this protocol can in fact be used for web applications as well, and it has been used for a lot of Windows services because it's very easy to integrate in your current Windows environment. So some of the services that actually use this includes MS Exchange, which you would otherwise know as OVA, which is basically on-prem services. What you can also see this service being used is in Exchange, or what you call Link for Business, if that word is familiar for you. You can also see that it has a lot of applications in Active Directory certificate servers where you have certification servers which are present there, which gives you certificates based on your request, which comes through. Some of the ADFS endpoints, which I'll get to in a little while, and also a lot of third-party services like Okta SSO, in fact, uses this to simplify your whole authentication scheme. So what it essentially does is, if you are using Okta and you want to tightly integrate your Windows authentication with Okta and not enter the two-factor, it does have a service called IWA, where it leverages on NTLM authentication. Moving forward, so the primary question here would be like, okay, you have talked about NTLM, so how do I actually identify these endpoints over the web? It's very straightforward, right? What you do is that whenever you're fuzzing a web application, and if you see that there is an authentication prompt which comes, you can see that it looks like a basic authentication prompt unless you look at the backend. So what happens is, this is one of the captures of an authentication request on Burp. What happens is that the authorization header is set as NTLM, as you can see here. And there is a whole base64 string that you can see, but if you decode that, it will not give your actual credentials because it's a challenge response mechanism. So this is basically an encrypted blob of text, and this is how you identify NTLM endpoints. So diving a little back into what response happens, what happens is that when you send this, the server responds with its own NTLM headers. You see a www authenticate header, and what you can see is like an NTLM SSP response, which basically has a lot of juicy information. It's basically a long base64 string. Why I have censored that is because this is live production data, and I don't actually want you to decode that by doing a screen cap. So that's basically what you can do with NTLM endpoints. Now, coming to the actual endpoint, what the impact is, right? What happens is that when you actually decode these NTLM endpoints, what happens is that you get a bunch of information from the server. So this base64 can actually be parsed with an NTLM SSP parser. And the good thing is that Nmap actually supports this in one of the NSE scripts. So one of the NSE scripts called HTTP NTLM info, it actually takes the NTLM SSP response and basically passes to give the bunch of data. As you can see, it gives the NetBIOS computer name, domain name. And this is important because this is not something that you would see on the internet on a regular basis, right? So let's say if it's Microsoft.com, right? What you would see is Microsoft.com is in fact the externally exposed endpoint. But when you parse this, you get to actually look at the internal endpoint of Microsoft, which could be contoso.com. This is just an example. So it gives you information on what is actually running behind the server, and it also gives you what is the root DNS which it uses. And as you can see here, it's an FQDN for the server which is running, which is the Exchange server. So this information is actually leaked when you parse NTLM responses. All right. So this is all about NTLM and that we required so far, and we'll look at the cloud 101s. If you're familiar with Azure AD, Azure AD is basically an Active Directory on the cloud. What happens is that when the cloud migration happened, Microsoft realized that you cannot just rely on the on-prem AD. So Azure AD came into existence, where you take everything on the cloud. And as you can see from this slide, which is taken from one of the talks that I really like. It's about attacking Azure AD. The link for this I have dropped in the link below. But what you can see is that Windows AD and Azure AD is nothing alike. It's different. Windows uses LDAP protocol for querying, while Azure AD uses REST APIs. And one of the things that actually needs to be that we need to be mindful is that Active Directory uses NTLM and Kerberos authentication, and this is basically what my talk will be about for the first bit. And then Azure AD doesn't use it, because what happens is that they realize this is probably not the best way to go about it, so they moved on to more open standards of OAuth and stuff. All right, and this is basically an overview of how Azure AD works. You have users and endpoints, and these users basically connect your on-prem Active Directory when they're on the internal network. So let's say you're in the office and you connect to the office Wi-Fi. What happens is that you connect to the Active Directory, which is present in the internal network of your company. And when you want to actually connect to Azure Active Directory, that is when you authenticate your Office 365. So let's say your company uses Office 365 for mail. The same reason you can use the same password that you use for your internal network is that because there is an Azure AD Connect, which basically connects your internal AD with the cloud. So the Azure AD Connects, what it does is it does a lot of activity in the background for syncing your password hashes and all those stuff. So that is the reason why you can use the same password in the cloud as well as in the on-premise. So this is pretty much all the one-on-ones that I had to cover. So let's actually figure out on how we can actually supercharge your discovery or supercharge your recon process by using these things. So one of the primary things, this has been covered by a lot, but I thought I should touch upon these. Finding NTLM endpoints is kind of important in your red team engagements because that is one-shot entry directly potentially touching the AD. Because whenever you send a request to your NTLM endpoint, you're in fact interacting with the AD of the domain, and that's important, right? So how you can find such endpoints is that you can Microsoft actually makes it very easy for us. So if you look at it, autodiscover.domain.tld. So let's say your company is Microsoft. If it's autodiscover.microsoft.com, is actually the recommended standard by Microsoft for having an auto discover service. I'll get to what it is in a little while. Bear with me for a minute. And the second endpoints is basically Meet and Dial In, which is used by Skype for Business or Link. And the last one is Link Discover, which basically enables companies to use Link. Also, I'll get to that in a little while as well. And the most interesting thing is that NTLM authentication is turned on by default on all these services. So you will see this a lot on the internet. And one of the questions I asked myself is that, should I really talk about it? This is 2020 and people are moving to the cloud. And I remember specifically watching one video, which was by Nick's Geek, and his talk was around how to attack link servers. And that was, I think, done in the late 2017s, where in his talk, he had scanned the Fortune 500 or Fortune 1000 companies looking for specific endpoints where you can find link or NTLM authentication enabled. And what he discovered was that about 50-ish% of the companies, in fact, had one of these endpoints which are available. So to carry on his research and to see how relevant it is in the late 2020s, what I did was that I gathered the list of NTLM subdomains that are usually found out in the wild. And you can actually check out the link, which is I have published it right here. And what I did was I downloaded the URL list of Fortune 500 companies and did a scan for these endpoints. And what I noticed was that about 65% of those companies, in fact, had one of these services exposed over the internet. And that's bad because, it's, as I mentioned earlier, it kind of is like one step to your Active Directory environment for authentication. And some of the main services that I came across was Link Discover, which is basically what is used by Link. There was also a little bit of Auto Discover and some services of Link, which basically shows us that Link is actually pretty popular among companies. In fact, it's an increase from the 2017 research. I'm guessing it's probably because of the current situation. Everybody is working from home, so companies are exposing basically what is more needed than usual. So link discovery, in fact, I was writing this link on why link discover does not, in fact, have any NTLM endpoint. But what it, in fact, does is takes you to actual services which have NTLM services running. So this is a very apt name, because I'm a huge fan of Marvel. So what better name than this? So it basically takes you where it is. So again, when talking about link discovery here, what it essentially does is when you visit the link discover domain, you see a XML page which basically has a lot of host names. And what you see is that if you take these host names and if you browse it on your if you browse to that endpoint, what you see is that that you actually have an NTLM prompt coming up. And this is important because what this does is because this is usually the internal naming schemes which are exposed on the internet. So this also gives you a fair bit of insights into how they name the servers, using which you can proceed with your recon. Auto Discover is again basically it's like a WPAD service for your Outlook. So if people don't know what WPAD is, it's basically a service which is used to discover your proxy settings in the internal network. So what you do with WPAD is that you query your system queries for WPAD, and then the WPAD server actually responds back with proxy settings that your endpoint is going to set. Experiences red team here, or people who have done internal penetration testings, know that we exploit this for responder. So it's basically something like that for Outlook. So Outlook basically reaches out to Auto Discover, sends a few requests to figure out where to go for the Exchange service. The path for it is /autodiscover/autodiscover.xml, and unlike link discover, what it essentially it does not expose anything by default, but it is protected behind an NTLM, and you have to actually go through the authentication before you can get that data. And I was like, okay, cool. But the thing is that I don't want to cover a whole lot of it, because that will take a lot of time. There are a lot of services available. So what I did was that I wrote a tool called NTLM Recon. What it essentially does is given a list of credentials, given a list of subdomains, what it essentially does is it fuzzes for certain endpoints which are usually seen out in the wild, which has NTLM endpoints. As I mentioned earlier, it sends a dummy authentication request to the server and then enumerates information from the returned NTLM SSP response. So instead of running NTLM Nmap manually on each of the endpoints, what it does is this tool does it all by itself. And all the information that you saw in the Nmap scan earlier, it kind of saves it as a CSV file. Coming to the functionality of the tool, what it can do is it can either take a single input to enumerate the endpoints and the domains, or what you can do is you can give like a bunch of files which with all sort of things like CIDR blocks, host names, IP addresses, and domains. Why I wanted it to be this way is that when you do a red team, what usually happens is that you are looking at a huge scope, right? So what I usually do is I have like a scratchpad where I throw in all my discovered stuff. So I put in ASN blocks that I find, or server blocks that I think are actually used by the corporate ranges and stuff into the file name. And what I usually do is that I take that and put it into NTLM Recon, and it basically fuzzes all the endpoints. One thing to notice that CIDR blocks are automatically expanded, and it sends an HTTPS request to each of this endpoint, fuzzing, looking for this endpoint, as you can see from the screenshot. And why this is useful is one of the case studies is that I usually do red teams on large organizations where one of the use cases that the ASN blocks are so huge that it's reserved for customers, and some of these are off limits for us. We are not supposed to attack them, and we really want to know which IP addresses are used for corporate ranges and which ones in fact used for customer ranges, and it's off limits. So what we usually do is that we kind of run it across the ASN range, and we look at the responses that we have received. And based on that, we can say, okay, this is probably customers and this is off limit. And we kind of look at the internal NetBIOS name and figure out, okay, this might be the corporate range and this is where we should attack. And some of the applications of using this tool is that, when you have a NetBIOS information, what you can do is suddenly it opens possibilities as querying for internal domain name over the internet, right? And what better places than Census and Showdown for that? So one thing I really like doing is that once I discover these names, I immediately go to Showdown and Census. I query for the FQDN of the server. I query for the NetBIOS name, which I found. So if it's contoso.net, I basically query it in these servers. And one of the most interesting things that is majorly overlooked is that every RDP service and SMB service, in fact, has fingerprints associated with it, right? So RDP protocol, in fact, has SSL certificates because the traffic is encrypted. And what usually happens is that, when you're configuring your internal RDP servers, it is usually the FQDN is going to be, some server dot the domain name, and these things carry along even when you are exposed on the internet. So what you can essentially do with this is you query for NetBIOS and FQDN names, and suddenly you expose, you find RDP servers which otherwise may not be picked up when you do initial recon, because those things are entirely different. Because what happens is that Microsoft.com is not same as contoso.net. If that is their internal domain name. So these things are usually missed when you do Showdown docs. But when you're weaponized with this information, you pick up a lot more. Same with Census. What you can also do is you can query based on SSL to find internal servers which are actually exposed over the internet. So in fact, these are actually real life examples. That's why I have blurred out the host names and stuff. When I was actually digging on one of the red team assessments, what I saw was that I found a web server which was actually used for an internal application which was exposed over the internet with this technique. And also one of the RDP servers, which can come useful later, if you have like a privileged account from phishing, and your shell got popped because you're using PowerShell, and let's say the blue picked it up. You can always use this credential to log into the RDP, which is associated with the company, and that's a good remote entry point for you. Other thing, what I really like doing is docking Google and GitHub using the NetBIOS names. Very interesting. I think one of the red teams I have been doing, what I found was that I was docking with the internal credentials, the internal FQDN on GitHub, and I saw one of the employees had in fact pushed this proxy credentials. And I don't blame him, because what usually happens is that every company has their own proxy. And people have, when they have to do development, what they do is they set up proxies for accessing the internet, and that is usually their domain authentication credentials. And developers usually have some level of privilege on the network. So I was able to find the developers' credentials just by docking using NetBIOS and FQDN name on GitHub. And you'll find all sort of other things like, if there is an MS SQL server, that will also have internal domain names attached to it, and you will find those information which you would otherwise probably miss in your recon. Okay, so that's pretty much about what you can do in recon. But now we have weaponized with some level of information about the target. We'll kind of see how we go about attacking these endpoints. To start with, I think what better service than MS Exchange, because this has been under scrutiny for many years. In fact, there was just a blog which came out a couple of months back about how to attack MS Exchange servers on Q2 2020. So I'm not going to be digging too much into the attacks, but I'll walk you through it. As you can see, the MS Exchange endpoints usually have a few services which running auto discover. We already discovered it. OA is basically the web application endpoint where you log into the mailbox. EWS is basically used for applications to integrate with Outlook. It's basically the backend applications and other softwares which need access to your web service. Exchange uses this protocol. ECP is a very interesting protocol. It's basically the control panel which came up with the latest Exchange services. What you can do with this is, if you have an Exchange admin, you can do a fair lot of things using ECP. OAB is something that is not very much explored, but it gives you an interesting attack vector because that's offline address book. So if you're able to get SIDs of employees, what you can do is you can take that and download the specific global address list and then export it locally to your system. So that's something you can do. And one of the most popular attacks, as you clearly know, some of you might know, is password spraying, right? So password spraying is one of the most popular ways, and probably one of my favorite ways, because what usually happens is that now that we have detection against a lot of C2s, and there are EDR and network solutions which pick up even the beacons for C2s. So phishing and then deploying C2 is probably going to go out of date in a couple of years, and that's something debatable, but I don't really like taking that approach. But what I do is I kind of stick with password spraying for some engagements where I know that the security is tight, and the logging, and there is EDR protections and stuff. Quickly on how password spraying attacks work, what you do is you find out the naming convention of the company. What you do is you can go on LinkedIn and you go on Hunter and find email addresses. It's basically the regular OSINT. You generate email lists, and then if you don't know what password spraying is, you try one password against multiple users. So that way you don't lock out users, and then you pray one of it hits. And then what you do is you wait for some time because you don't want accounts to get locked, and then you rinse and repeat it again. And one of the best ways to go about password spraying, I would arguably say, is through the /OA endpoint, because it gives you the added advantage of actually getting to know if the password is expired, if the password is successful, and it also, what it does is it enumerates the users in the backend. So if it's like a valid user, what happens is that you have a very short response time, and then if it's an invalid user, it takes significantly higher time for OA to respond to it. So as you can see, the red box is basically for a failed login. It took about 3 seconds to give a response. It also tells HTTP redirect with reason to. If you see that in your password spraying, it's most likely this user is not present. Fail login, but username is valid. That happens when the password of the user had expired, and even though the password is right, you won't be able to do much. I'll get to this in a little while. And what you also sees that you have a successful login and where the password has, the login has failed, but username is valid. That's still a valid vector because you actually get to know that user is specifically there. So the second time you're doing password spraying, you can just remove all the failed logins with HTTP redirectories into and do a very focused one. Let's say the OVA was locked down by blue team. What you can also do is you can go to the /EWS endpoint, which is basically an NTLM endpoint again. Unfortunately, this does not support enumeration. There has been some attempts to time the attacks on these endpoints, but usually those have not been successful or those are not very reliable. And what you can do is you can also spray to this endpoint with a supported tool. So if you are using a tool like, let's say, ByteBleeder's password spraying toolkit, or you can even use Mail Sniper, what happens is you can spray any NTLM endpoint that you need. And in this one, it's very straightforward. It's either going to be failed login or successful logins. Okay, so we talk about how I actually go about password spraying, because this is something that I have been talking to people. So what people usually do is they restrict to the domain names or the domain names that they have found on LinkedIn, or they go with statistically likely username is the maximum. And I ask them why, because I have done a lot of I've considered amount of red teams, and what I've seen is that people make all sorts of accounts. It's not just employee accounts. So what happens is that service accounts are made left and right all the time in a company, and these things are usually forgotten. So what you do is one of the favorite things that I do, and where I have seen a lot of success, is using a very crazy word list as API _ word list. So what this word list essentially has is like a list of endpoints which APIs might have, like Swagger, SharePoint, and all those things. And what I've noticed is that I just strip off all the numeric stuff from the word list and just use the ASCII character based ones, and then it usually hits. There is usually a service account by that name. It's not very believable, but I have got a lot of accounts by this way. Second thing is something that you all might be already looking at. So it's basically statically likely usernames, which basically is a repo where you can generate your own usernames if you know the scheme, and you can get the naming scheme either from a service like Hunter, which basically does that for you. Or what you can do is, if you are like a person who does threat intelligence, what you can do is you can dive into the Breeze databases. These things are not easy to get. You just have to know where to look. For legal reasons, I won't be sharing where to get these things, but there is disclaimer that the legality of owning these databases is disputed. Like, there is no legal grounds for this, so be careful while doing that. So if somebody asks you who asked you to do it, don't point them to me. And obviously the rule 101 of password spraying, company at rate 123, password 123, these stuff is worth trying. And one thing that I've actually argued a lot is that people say that you can't have passwords like test 123, 123, 4, 5, 6 at company 123, because most companies have the password complexity set as upper character numbers, and these can't be valid corporate passwords. But what I've seen is that these things usually work, because I'll talk about why in the next slides. And the last one is move away from single-threaded tools. If you're using Metasploit, it's now is a good time to move to async tools based on Python. Again, ByteBleeder's spraying toolkit is a very good example of how asynchronous spraying can actually save a lot of time for you. Although it's very noisy, I think if you are a person who likes to get stuff done and move fast, this tool actually helps. So this is what I was talking about. So this is basically a case study from one of my engagements. I'm not sure if you can see this. I'll just talk about what it is. So the first screenshot is basically what I've done is I've queried an API endpoint, and I have filtered by account enabled true, and I have looked for all the accounts where the password was changed before 2020. This is a very recent engagement I did, I think 1 month back. So I wanted to query how many users were there who were in fact changed password before 2020. I could show about 1,000 accounts where passwords were set on 2019. I went a further step, and then filtered for any accounts which had passwords not been changed for 2 years and were still active in the domain. And there were about 269 accounts. That's using word count minus L. I removed that and I put a sort. And to my surprise, what I saw was that there were like a lot of accounts where the passwords were last set in 2003, 2005, 2010. And in fact, one of the accounts I got from password spraying the password, but if I'm not wrong, was last set in 2010. So those were the times where password complexity was not that straightforward. And one of the passwords I found was, I think, test123, if I'm not wrong. So that's what I got. And that was a service account which actually had a mailbox attached to it. I'm not going to spend too much time on attacking Exchange after credentials. I have dropped a reference for it. I talked about that wonderful blog, which basically lists all the attacks that you can do. I'll just summarize what you can do. One of the new attacks that have come out is that actually using Exchange, by using the ActiveSync protocol, what you can do is attack access shares of internal shares. There are some limitations onto what UNC paths you can access, but this is something that you can actually work on. And one of the second things you can do is that you can actually log into Exchange services using a tool like Ruler, or using OAB extract at the endpoint I was talking about, and you can dump the entire global address list of a domain. That's dangerous, because what happens is that suddenly from a guessing game, you're suddenly weaponized with the list of all the domain accounts in the domain. And what if you get an expired password? Because this is something that I always come across. Whether you are doing docs and finding out accounts from GitHub, what usually happens is that because of the password policy the company sets, the passwords are usually expired. And if you try to log into OVA in certain instances, it does not allow you to log in. Some OVA does in fact actually redirect you to this page, but some of the OVAs are hardened not to do it. But no problem, you've got it covered, because if you force browse yourself to /over/expired password.aspx and prevent a redirect on your browser, you will actually land up on this page where you can actually enter your domain /username that you find. And that domain, in fact, if you remember, is exactly what we found using a tool like NTLM Recon. Or what you can do is you can browse to /EWS and find what the domain of the company is. You enter domain /username, you enter the expired password, and you enter the new password, and suddenly you have actually reset the password of the user. And this is a big thing, because what happens is that to be able to reset passwords of domain accounts, you usually have to be in the network and you have to do a Control-Alt-Delete. Right? But what OVA does is that makes it very easy for you. This has to be enabled, I think. But this what I've seen is that this is enabled in a lot of places. And in fact, one of the key features that they use OVA is actually for changing passwords. So you can do this. And one pro tip, or one tip that I've come across, is that you essentially don't need to have a mailbox account. Like, it can be any domain user account, and you can change password for that user. What I've also come across is that there are middlewares like RSA, which basically claim that they can stop people from attacking OVA or Exchange altogether. So people just throw in a middleware of RSA onto the endpoint. But this also doesn't do much, because what you can do is you can obviously again access /EWS. The reason is that this application works on the application layer, which comes after IAS. But what happens is that when you browse EWS, your authentication happens with the IAS server. So there is no real way a middleware can stop that unless you entirely lock down that endpoint, which most people don't do. This again, the URL is changed, but this is in fact again from a real endpoint where it was actually protected with RSA Secure ID, but in fact I was still able to go around it by using EWS. And you go all the way, you put in your extra efforts, you spray your passwords, you finally find that one account that you need for pivoting into the network, and then you see this. This is very disheartening, because I have come across this a lot of times. This usually happens because the company has already moved to a cloud-based service like Office 365, and you will have to actually log in there. So this is basically exactly like what you see in Mario. You take all the efforts, you eat your shrooms, and then you come to this end and you say that okay, hey Mario, thanks, but the actual end is not here. You have to go further. Again, so what you do is that once you stay here, you move on to Office 365 because that's where all the good stuff is apparently. Now here, Office 365 presents its own challenges because there can be multiple login names per organization. So account@ponfu.com is basically assume it's the public domain name, and that's where the email is hosted. But what happens is that service accounts usually don't have that because it's not intended to be logged into Office 365. But what happens anyway is during migration, all your AD assets are auto-migrated. So if you remembered from the 101 session, what happens is that you sync your Active Directory with your Azure directory. So all of your accounts, in fact, come onto your Azure AD. So the Azure AD does not get the ponfu.com email address for service accounts. In fact, what it does is it creates your tenant.onmicrosoft.com domain. And the problem is that it's not necessarily the same. What I've seen is that there are a lot of organizations out there where the public name essentially does not mean the same. In this example, it's same, but sometimes it's not. And this creates an enumeration problem because here you will only be able to access employee accounts and not service accounts using the on Microsoft one. And this is a problem. So we have, how do you actually find this tenant name? Well, there are some steps that you can do. This first one is the URL that you see for well-known OpenID configuration. The part where I've actually highlighted in red. So if it's a valid tenant, it basically responds with a bunch of which JSON where you can send your login request to login.microsoft. That's one way. So all you need to do is that you need to fuss the onmicrosoft.com and figure out what that tenant ID is for your service accounts. And what usually you can do is that you can go to their homepage and you can make multiple combinations of the domain. One thing that I actually like to do is Mail Spray. I think Mail Sniper, in fact, has a module to make multiple host names and multiple domain names. I basically key in the company's entire addresses with spaces, and it generates a list of accounts for me to try, and that has usually worked for me. Now, one of the problems with this approach on this endpoint is that login.microsoftonline.com is actually throttled by Microsoft. So if you're doing enumeration on this, what happens is Microsoft kind of mess around with you and gives you valid for all the other emails. And this is what happened with some of the user enumeration tools. What happens is that after a while, it basically gives true for all the requests, and that's not good. So what I was doing a little bit of research on this, and what I saw was that I came across this endpoint password reset.microsoftonline.com, which basically lets you reset your password on Office 365. Now, if you see the left screenshot, you'll be thinking, okay, hey, there is a CAPTCHA. You can't be expecting me to solve CAPTCHA for every single request, right? That's not what I'm saying, because what I've noticed is that once you enter your user ID, it doesn't matter if it's actually @onmicrosoft.com or just your domain. If it's the valid tenant, it will return a branding value. So if you can see in the right screenshot, I entered I don't exist @Microsoft.onmicrosoft.com. It's very evident that this probably does not exist on the Microsoft tenant, but it still gave me the branding ID anyway. One drawback, or I wouldn't call it a drawback because most organizations has an Azure Premium. This branding information can only happen if you have an Azure Premium, but that's none of the worry because every organization who's in fact on Office 365 has a premium. How this enumeration works is that when you enter your user ID, there is an AJAX request which goes to the backend with the username. If it's like I don't exist at Microsoft.com, it looks at the tenant part. And if the tenant exists, it in fact responds with the image. And this one is not throttled. I tried sending about 10,000 requests to this endpoint, and I was not throttled, or it did not give me false positives at any point of time. So this is a good endpoint to work on. And currently, there are no tools which are doing it, so you'll probably have to do it manually. But this is where all the good stuff is at if you want to enumerate the cloud. Some of the gotchas when you're enumerating is that if a user has a public domain like the ponfu.com, what happens is the same user's domain, it will not work for onmicrosoft.com. The reason is that onmicrosoft.com is usually used for the internal NetBIOS. So if you look at the screenshot, this is one of the examples that I have. Karen@ponfu.com is in fact the public email ID of the user, but Karen W@ponfu.onmicrosoft.com is different for that user. That's the reason, because what happens is, I'm sure all of you work in corporate environments. Your public email address is not the same as what you see for the NetBIOS. So the name you're seeing there is in fact your internal NetBIOS name. Again, spraying accounts on the cloud, there is a tool which already does it, MS All Spray. What it does is, it's basically here in the screenshot. In the interest of time, I'll skip it. It's already implemented in the tool and you can use it. As a difference for password spraying, what Microsoft did is that they came up with Azure AD, this solution in Azure ID, where you can actually set up a blacklist and then throttle it. So if you're trying to spray Azure AD, you're bound to get throttled. And the workaround for this is, again, this has been discussed, I think, by the good folks at Blacklist InfoSec. They write wonderful tools. The first one is, in fact, Trevor Spray, which uses SSH. It's not a good thing because, unless you have like a lot of SSH-based host names, it's going to cost you a lot. Instead, what you can in fact do is use Fireprox, which leverages AWS API gateway. And what it does is it's kind of proxies between you and Microsoft, and the IP changes for every request. And that way you can actually work around the smart lockout. And the free tier, in fact, supporting about 1 million requests per month. So you're not gonna get choked by the bill. So when you're authenticated, what you can do is there is a tool called OfficeStage Recon, using which you can get all the information about the Azure tenant. You can also pull down the list of all the users who are actually, in fact, present on the domain. And this is, in fact, same like what you do with Exchange. You just get the entire global address list, but this is just from Exchange. What you can also do is, once you have an authenticated session, you can use Graph APIs, and then you can do whatever you want as a user. One of the sample things that you can do is you can actually dump the entire global address list by authenticating to Azure Identity. This is kind of hard to detect, because what happens is the other tools which basically does authentication logs it on Office 365 portal. The logging is there, but what happens is when you authenticate to Azure Identity SDK, the authentication, if I believe, goes to Azure AD directly, and using that, that's a good way to dump the gal. And a sample code of that, I have put it on the link for you to explore it. It's not complete, so if it's broken, just send a pull request or open an issue, and I'll look at it. And one of the better tools out there, which came out very recently, is ROAD Recon. So I'd like to spend some time here. So what happens is that, especially if you're a red teamer who does phishing, and if you manage to use a proxy or a proxy-based service like Evil Nginx, what usually happens is that you get the cookies as well. So one thing you can do is, in fact, use ROAD Recon to access Office 365 using the cookies and get all the good stuff from there, as I put in the box. What you can also do is use the device code authentication method to, in fact, not bypass, but go into an account which has MFA available. So ROAD Recon basically has a GUI which gives you a whole lot of information on users, groups, and other stuff. And little while, I'll talk about that in the next one. What you can also do is, once you have dumped the data from ROAD Recon, what you can do is you can look at what employees have what privileges. So let's say if you are looking to get into the VPN, you can exactly know which users are part of the VPN. So that's something you can do. You can also get very specific information. So if you notice the Karen W versus Karen screenshot, that was actually from ROAD Recon. So if you log into Office 365 as any user, what you can do is you can pull the list of all the employees and their internal NetBIOS domain names, and that's very useful, because then you're able to access any NTLM service which is out there. And one of the better things that I like using this tool is actually for accessing MFA and looking at the poster of MFA. So if you look at this is from a real engagement. Their MFA was enforced on all users except for some users with MFA_access exception. So I was able to specifically one of the accounts that I was able to compromise did not have MFA, and I was able to log into the finance systems and all from Exchange. So this is also a good angle to look at. So long story short, what you can do is you can load a lot of things. You can enumerate users, groups, permissions, identify the privileged users, especially if you want to phish them directly. You can look at audit policies and then look at the weaknesses in that. You can also find low-hanging and forgotten users who are active. In fact, you can use that and then do a lot of activity. And then, in fact, it also gives you API access so that you can get hold of the data. And some of the things that I, in fact, also like to do when I get these credentials and get the NetBIOS names is first for certificate endpoints. So these endpoints are default found as SSL servers, IIS servers. So what happens is if you put a /CRT serve and then a post request or get request, what happens is this page comes up, and this is basically the Active Directory certification services. And why this is important from a perspective of red team is because of that. If you have a domain credentials, the only thing that is probably stopping you is either a two-factor on the VPN or a certificate service on the VPN. And this service kind of solves the problem for us. You can log into the service and you can fetch a certificate for yourself. And if you have to use Internet Explorer because it installs it directly for your service, and then you can log into the VPN using the certificate. And also, one of the things I like to look for is port number 7004, which is used by RSA. And there are like a lot of other two-factor services there because MFA portals logins usually don't have MFA. And this is directly connected to your AD, so you can just use your AD credentials here. And that brings me almost to the end of this talk. So what can the blue team do, right? The primary thing is basically disable NTLM endpoints across network because, as I said, it's one-shot authentication to your AD, and you can all lock down all the endpoints, and that information is put in the link. And one thing is the enforced password blacklisting on Azure AD so that people don't use weak passwords. And if you're on blue, you can do is offensive defense, where you audit your NTDS, take dumps from it, and blacklist all the common passwords. You can also add rules around 4625 event IDs where you detect user enumeration using the flag. MFA, all the things. It's probably too late to say this because this has been going, but you should also look at starting your passwordless or FIDO-based journey, which adds a lot of complexity. Finally, deploy honey tokens and honey accounts to detect compromise. And the final and the most important thing is that if your service accepts domain credentials, and if it's if it's on the internet, you're probably doing it wrong. So you should have a talk with your IT or probably whoever is responsible for your infra and take it behind the VPN so that this does not come and bite you in the back. So this was all for my session. I hope you learned a thing or two from this session, and I'm really looking forward to all the questions that you have. So if you have a question, this is a good time.